Hi, everybody. Hello, everybody. Um, Thank you for being here. Let's give a round of applause to Abhishek. He will be talking about edge zones in CloudStack.
Hi, welcome guys. Welcome to this session for S zones in CloudStack. My is it? Oh yeah. Okay. Hi, welcome everyone to this session. Myself Abhishek Kumar. I'm a software engineer at ShapeBlue. I'm also a committer at Apache CloudStack project. So you might have seen me with some PRs and issues on the GitHub. Uh, this session is deals with as zones in CloudStack. Get your cloud edged. Not something we will be talking about. So let's see the agenda for the talk. We will be discussing first what's edge, why it is needed, some typical characteristics for it, some use cases which will be quite important for going forward in terms of cloud computing. Then we will see what zones in CloudStack are, although I think everyone might be having that idea. Its structure and deployment, challenges with traditional CloudStack zones that we have, which make them not that suitable for edge deployment. Then the edge zones in CloudStack, their structure, how they are deployed. Little bit about the supported functionalities, core versus edge comparison. We will try to do a short demo depending upon the network. And lastly, future work, your feedback and suggestions. So let's get into it. So what's edge? I think everyone might be having some idea about it. It refers to the network parameter bringing compute near to the end user. So even a home router can be seen as a edge device. Uh, with this slide, we can see we have come around quite a bit. So from mainframes to PCs and client server architecture, then going to mobile computing. And now it seems like it will be edge or edge computing that will be dominating going forward. Again, a short description about edge computing. So, not particularly about computing, but more about it is more about network architecture, which brings data and the compute near to the source or the end user. Uh, like in the morning, Simon mentioned about the hype curve. So based on that, we can see edge platform as a surface is at the top of the curve right now. So it might go in productive or enlightenment phase, but it is something we will have to see. So maybe in next 3 to 5 years, it could be a more important talking point in terms of implementation for end users. Uh, right now, it can be seen as more important for maybe product people to pitch to their users and uh, more than implementation. Similarly, if we see hype curve for edge computing in itself, we see a lot of services with regard to edge. Some of them may die off, but some of them may be reaching a stage of enlightenment. Like we can see edge computing itself might be reaching somewhere towards enlightenment stage in maybe next year or so. Typical characteristics of an edge site. So in most cases, it will be a single host, low power device that won't be sharing any storage and everything fitted into a one piece of hardware. There could be high latency in terms of connecting to the data center or main server, but it tries to offer lower latency or responsiveness for end user. And then security and privacy matters, as we talked about in the morning about data protection and sovereignty. So this is something that definitely could help cloud operators going forward. Some use cases for applications on the edge. We can see different virtual network functions, parameter firewalling, Internet of Things, which has been dominating something based on that. Software-defined WAN, then secure web gateways. So it comes down to different network functions that can be deployed on the edge. In terms of control, it can be seen in industrial automation, point of sales terminals, and things like that. Similarly, it can be useful for analytics where data needs to be analyzed and stored closer to where it is generated and consumed. So it could definitely help in real-time analysis. Uh, a good example can be a fast food chain running a hybrid cloud with maybe thousands of sale points. It could be running on-premise cloud for different activities like management, HR, and all. Then it would be also running those thousands of edge deployments for inventory management, point of sale, things like those. It is a highly distributed rough environment. So a traditional architecture in terms of large data center would not fit in this use case. So it could be seen as a probably a best example for edge deployment. Next could be factories where a lot of automation is going on, a lot of sensor data that is being collected, and it might not be relevant for storing that data to central server because it needs to be evaluated and analyzed in the real time and maybe not that useful later. Next, it could be mobile edge computing, like autonomous vehicles, where uh, they they are trying to connect to different edge nodes. So things like those. Similarly, augmented reality, virtual reality kind of things, where the site itself is moving. So things like those. Next, we can see outside or in physical form, an edge device could like one of these. It might be having few cores of CPU and storage themselves. So these could be a basic example of edge device. Inside, it could be quite different. So it could be using SD-WAN VNF, virtual firewall, running some user VM. So this could be a basic edge device we can think of. Next, coming into zones in CloudStack, already everyone of you might be knowing what zones in CloudStack are. So typically they correspond to a data center, although A data center can have multiple zones as well, but in general, a single data center would become a CloudStack zone. Uh, with this new feature, a traditional CloudStack zone will be termed as a core zone in the UI and a database. So this is what a zone in structure looks like. There would be a number of pods which would contain a number of clusters, and then in those clusters host will be organized with some shared primary storages. uh, in a zone, there would be a secondary storage, multiple physical networks to work with different traffic, public, guest, and management, storage, etc. So uh, this might not be a suitable uh, deployment for an edge site. Going into how zones are deployed, like if we talk about current UI and how workflow there is, we add some zone details, then some physical network details, add a pod, cluster, host, and then primary storage, like shared primary storage, some secondary storage, and try to launch. So it for a S site where maybe thousands of deployment to be done, this is a lengthier process. So uh, going into challenges, how CloudStack zones are not suitable for maybe edge deployment. From business point of view, uh, they are resource intensive. They need a lot of resources, both in terms of hardware and then a lot of people to manage them. Everything is centralized, so it brings in things like latency and compliance issues as well. Not very cost efficient when we talk about working with edge sites. So yeah, these could be some business challenges for deploying traditional zones with thousands of edge sites. In terms of technicality, as we talked, they are not scalable for edge paradigm. So like something like they required shared storage. There will be some shared secondary storage. So uh, this is not something an edge site can have. Deployment is complex. There will be system VM overhead. So if edge device is running with a 6-core CPU, two of them could be used by system VM itself. Then they also need dedicated management range. So uh, this is something would be very hard for deployment of thousands of edge sites. So uh, this is why a different structure is needed for edge deployment. If we see how traditional core zones and edge zones currently look like in terms of a large deployment, it could be a regional data center, local data center, and then number of edge zones. So if we talk about that fast food example, there could be a regional office for them, and then a number of outlets in same city, around same area, which could be seen as edge zones or edge deployments. Now coming to edge zones, the feature, this will be coming in 4.18. That will be the next release of CloudStack. Also, it adds a new dimension to CloudStack. As I already told, it brings the concept of core zones and edge zones in CloudStack. So some schema changes have been made. that already existing zones will be termed as core zones, and new deployments that are used with edge flag will be edge zones. There's a active draft PR on GitHub, which you can see and review comment. So yeah. Going forward, edge zones in itself will be lightweight, low-cost zones for edge sites. It will try to bring all those things that we talked in earlier slides, like low latency for end user, data sovereignty or compliance in itself. So it would allow consuming compute and storage resources close to the user, incorporating all the ideas of edge computing in itself. Uh, Again, the structure of an edge zone, typically there would be a single host. An operator won't be needing to add cluster and pod themselves, but they will be there. CloudStack will try to automate that process. There will be a physical network for guest traffic, so that would how it work. Next, deployment of edge zone in terms of UI. It would look like adding minimum zone details like name. In future, maybe hypervisor. Currently, it is limited to a particular hypervisor KVM. We will talk about that later. Adding network details, minimum details like VLAN for physical network guest traffic. Then directly going into adding host for the zone. So it would make deployment much more simple. Coming into supported functionality in an edge zone, almost all the operations will be supported, which are supported on KVM hypervisor. So it is currently specific to KVM right now. Then it can deploy L2 and shared network. So something like Kubernetes cluster can be deployed over shared network. So you don't have to worry about all the networking things when running with Kubernetes there as an application. So also it only supports direct download, so no need to use shared secondary storage. Zone will work without SSVM and no secondary storage needed. Though some of the functionalities that depend upon secondary storage, like backup, volume upload, template upload, may not be there. If we try to summarize what will be functionalities in terms of core versus edge, this will what it look like. Uh, as we can see right now, only KVM hypervisor, no need for shared storage. Currently, we don't support isolated network and VPC, but they support for shared networks and L2 networks. Okay, now let's try to do a demo. I have this environment running with KVM with CentOS OS 7 hosts. I have a host running with a particular IP, so I'll try to add that. In the UI, we added this new flag edge zone. So once selected, a different set of operations will show up. We just need to pass zone name. Give a name for physical network. Add some VLAN range. And directly we go to adding host. It will try to do all the operations that a normal zone will have. If I try to open it, this may take some time. So I have another zone running as an edge zone. So this is an edge zone. Currently it has a single host. So if I go into host, it will show me one particular host that I have. Similarly, if I try to see primary storage, while deployment, it automatically adds local storage for the host, for my KVM host. If I try to go in system VMs, so there won't be any system VMs for this particular zone. My zone was demo edge, and there are no system VMs running on it. In uh, inside VM, I have a VM running with L2 network, so it is running fine. Uh, Currently, we don't support console access because there is no CPM. We'll talk about it, how in future it is going to be added. Okay, so this is something we are gonna work in future, like adding support for other hypervisors as well. So apart from some of the challenges, oh, yeah. So for future, as I was saying, we are gonna add support for other hypervisors. Currently, we only support KVM. So things like direct download templates will have to be extended for them as well. For VM console access, we are thinking about doing it through KVM host and management server directly. We will look forward to your feedback. Adding support for other networking models, something like isolated networks and VPC. So some rethinking may be needed there, how we are going to support that. We talked about support for shared networks. So our direct download system VM template need to be added by operator for that. So something to be noted. Finally, facilitating management control plane. When the host or edge site, edge device is on only on internet, so uh, supporting that in terms of connectivity. And finally, some fine tuning and polishing of UI. Uh, Thanks your feedback and questions. Maybe I would like to ask someone who is deeply passionate about this, Alex, to add something if he wants.
Hello, hello. Wow, Abhishek, thank you. A zone without secondary storage in VR. It already sounds fast.
Thank you, Abhishek. Yep. Just a quick point on this. I worked with edge deployments in the past, I wanted to use CloudStack for that. But the definition of the zone was just too complex, too much overhead. As Abhishek pointed out, a single small host, you can have secondary storage. So we built this new construct of the edge zone, and that's really somewhat of a paradigm shift in CloudStack. Typically, in a deployment, you might have 20, 30, 100 zones. When talk about edge, we can be thousands and thousands, and as he presented, they might not even be in the same place. Might be a moving train, a moving truck, and can potentially grow to the millions. So there will be more challenges on how the database scales, on how the KVM agent talks back to the management server. There are some challenges that we haven't addressed yet. How do you connect the edge device back to the management server? There are many options. We would like to discuss ideas with the community. Thank you.
Thank you, Alex. A big round of applause, and let's go to questions. So Wei is asking, can we use a lightweight database like SQLite?
Yeah, that could be something we can look forward in future. But right now, it would be too big of work to shift entirely to a new database structure.
Yeah.
Firstly, guys, congratulations. It's fantastic work and very exciting. To continue on to your point earlier, that mechanism of networking connectivity, I think, is probably key to the success of this. Yeah. So having some sort of tunnel transport, right, that is auto set up would be obviously, I think, a major push for this technology. Was having to obviously build a VPN construct outside of CloudStack just makes it so much more complicated to deploy. So whether you could, put up a GRE tunnel at the very least, or OpenVPN or something in order to bring all that traffic back, I think that'd be fantastic. But it's awesome work. So congratulations.
Yeah, definitely, Simon. This is probably something similar to IPv6 that we worked on. There was a lot of discussion how to implement, how to go about it. We started with static routing, so this is definitely something to start with. We are gonna see how it works.
Okay, moving on to Venko.
Thanks. Great work. Two questions. So first, do you plan to have some management plane components on the edge zones that will help control the zone locally? And the second one is, as Alex said, typical use case might have thousands of edge zones. Do you plan to have some tooling or automation that will help creating zones instead of creating individual components using the API?
So one of the ideas that we are working on is for the edge device to be able to call home to CloudStack management server, place it somewhere behind a proxy, where then it can get its configuration, create a management tunnel back to the management server, and then it can manage all the components locally. That could be a further step where you just have an edge host and you have some information of what you want to run there and how, and then the zone can be created automatically. Something to explore.
Yeah, probably something we would be discussing on mailing list in future. Currently for 418, there is no like tool as such for doing it for 1,000 hosts or tunneling as we talked about.
Thank you very much, everybody. Unfortunately, we are out of time already, so a big shout out to Abhishek and Alex and everybody working on this.
Thank you, guys.